We are on the photoelectric effect. Photoelectric effect. This branch of physics deals with the conversion of light energy into electrical energy. So the word photo refers to light. Therefore, the electric part is where the current is produced. Therefore, the light, as we studied in grade 10, we had that light has got dual nature, meaning that it has got wave nature and the particle nature. Now, in the case of wave nature, we know the properties of waves. Waves can be refracted. Waves can be reflected. Those are properties of waves. And in this case, meaning that now light can travel in the form of a wave. Therefore, we can calculate the speed of light using the wave equation. Since the speed of light is constant, therefore, that's why the formula C equals to F multiplied by lambda, where C is a constant value of 3 by 10 to exponent 8 meters per second. In case of the particle nature of light, we learned in grade 10 that light consists of tiny particles which are millions in number, then which are called photons or quanta. Remember, one quantum, many quanta. Then what is a photon? We were told in grade 10 that a photon is an energy packet. Energy packet. Therefore, hence we can calculate the energy of one photon of light. In this case, the energy of a photon can be calculated using this formula, E equals to hf, where h is said to be Planck's constant. The Planck's constant, and this Planck's constant has got a value of 6.63 by 10 to exponent negative 34 joule second. That is Planck's constant. So what if we are not given the frequency of light? Because we know that lights have got a frequency, or beside the frequency, if not given, they might give us the wavelength of that light. Therefore, if given wavelength, then our formula will be hc over lambda, whereby h still remains Planck's constant and c is the speed of light in air, and the lambda will be the wavelength, which we know that is the distance between two consecutive points in phase, or consecutive crests, or consecutive troughs. Now that is grade 10. In grade 12, now as we move past grade 10, grade 12 says to us, let's learn more about how light, now energy, is in a way producing electric current in this phenomenon of photoelectric effect. We call it a phenomenon or a process. So phenomenon or a process. So now this process, it involves whereby now a light coming from whatever source is incident on a metal. Now, since we know that metal are shining, what makes metal shining normally is because of floating electrons around the metal. If we use chemistry, we know that in chemistry the center of any atom is the nucleus, which is positively charged. Therefore, electrons are the particles that are normally exposed to any actions that is coming from outside. Therefore, when light is irradiated on a metal, the particles that will be exposed will be electrons. Now, each metal, as we know, that is has got its own the so-called natural frequency or threshold frequency. Now, that frequency is the one that is either these electrons that are floating around the metal will be having the same frequency as that of the metal. Therefore, any radiation that is coming, where now there are photons in that radiation, many, then for a photon to displace or eject or emit these electrons, then they have to beat their frequency. Now, the process which involves the ejection of electrons from the metal surface by means of energy of radiation. Therefore, this process is called energy of light. This process is called a photoelectric effect, meaning that in this one we'll be now learning that when light is incident on a metal, then which that metal has got is vibrating at its own natural frequency. This frequency is said to be threshold frequency, or cutoff. So in some books they talk about cutoff frequency. Now, then if light is incident on that metal where electrons are floating, then if the frequency of this light, for argument's sake, is 2 by 10 to exponent 14 hertz, mean that every electron floating on that metal will be vibrating at this frequency. Therefore, any radiation that is incident on that metal, if electrons has to be emitted or rejected, has to beat this frequency. Therefore, that's why now when we define this frequency, we'll say is the minimum. So the minimum frequency required to eject electrons from the metal surface. That's what you call threshold frequency, meaning that for electrons to be ejected, the oncoming radiation, the frequency of a photon of oncoming radiation must be greater or equals to the threshold frequency. That's the first condition. So now we know that if a radiation has got that frequency, therefore that radiation also, the oncoming radiation, if it's having the frequency, which we say it has to beat the threshold frequency of the metal, we know that with frequency we can calculate the energy of radiation, which is equals to HF. Also, in the case of the metal now, we can also use the threshold frequency to calculate the energy of that metal, then which is called this one now your WO, which is work function. And this work function now, by calculation, we can say also it will be work function will be frequency multiplied by the threshold frequency. Therefore, what is a work function? By definition, the work function is defined as the minimum energy required to eject or emit electrons. In this case, sometimes you call them photoelectrons because of light, electrons from the metal surface. Now that's the work function. Therefore, as I've already said, work function can be calculated using Planck's constant multiplied by the threshold frequency. In the same case as the energy of a photon,